Hi, this is Matt Baker. Welcome to episode 3 in my series on the evolutionary tree of life. Last time we looked at the transition between fish and early land animals, including amphibians. We then concentrated on reptiles, including the really big ones, the dinosaurs, that dominated the Mesozoic era. Finally, we discussed the only group of dinosaurs to survive the KT extinction, the aves, or birds. Take note that if you missed episode 2 and/or episode 1, you can find a link to both of them in the description. In today's video, we're going to look at the other major branch of land-dwelling vertebrates, mammals. This part of the tree is particularly interesting because it includes the branch that led to humans. So nearer to the end of the video, we will be diving into the latest research on the evolution of the genus Homo. But before we begin, just a reminder that the chart I'm using for this series is available as a poster over on our website, usefulcharts.com. You can buy it in either a regular size or a jumbo size. Just click the link in the description or pinned comment to check it out. Okay, last time I pointed out this circle here, which represents the very first amniotes. Amniotes are so named because in their embryonic stage, they grow inside an amniotic sac. In egg-laying creatures, this sac is located within the egg itself, alongside a separate sac called the yolk, which eventually gets absorbed. However, in live-bearing creatures and humans, the amniotic sac grows inside the womb and then ruptures just prior to birth, which is when we say that a mother's water has broken. The earliest amniotes would have all been egg layers, and the first ones likely evolved around 320 million years ago. But very soon after that, they split into two groups, each going in a very different direction. This fork in the road, so to speak, is one of the most important on the entire tree because it basically splits the entire top into two parts. On the right side are the reptiles, dinosaurs, and birds, which we discussed last time. And on the left are the mammals, which we're about to get into. The technical term for these two groups are sauropsids and synapsids. As I mentioned last time, sauropsid literally means lizard face. But what about the word synapsid? Well, the word synapse means something like connecting arch or bridge. Therefore, we could say that synapsid means bridge face. To better understand this word choice, let's take a look at some skulls. This is the skull of a coyote, which is a synapsid. Notice this part here? It looks like a connecting arch or bridge. Most synapsids have this feature, whereas sauropsids, as represented by this T-Rex skull, do not. Another key difference is that synapsids have only one opening behind each eye socket, whereas most sauropsids have two. Now, we humans are also synapsids, so you can actually feel that connecting bridge on your own face. It's right below your temple being what's left of that single opening behind the eye socket. Basically, this bridge connects your cheekbone to the place where your jaw begins. That's why when you chew, you can feel the muscles moving in this area. The earliest type of synapsids, such as Dimetrodon, were originally called mammal-like reptiles. That's because on the outside, they looked like a reptile, even though on the inside, they were starting to develop mammal-like features. Later, they were called pelycosaurs, which is the term I use on this chart. But note that I put it in quotation marks. That's because officially this term is no longer in use either, even though in common speech it's still the name that most people use. Technically, it's better to call creatures like Dimetrodon proto-mammals or stem mammals because even though they looked like reptiles, they were not. Now, in episode 2, I introduced this chart called the geologic timescale, which divides the last 540 million years into 12 periods. Well, pelycosaurs lived during these two periods here, the Carboniferous and the Permian. But then during the Permian, they were replaced by a new kind of proto-mammal, the therapsids, which included cynodonts, meaning dog-teethed. These creatures managed to survive the massive PT extinction event, and then really started to thrive during the early Triassic. So, in other words, proto-mammals were around before the emergence of the dinosaurs. In fact, up until the mid-Triassic, the synapsids were the dominant land animals, not the sauropsids. It wasn't until the second half of the Triassic that the archosaurs, and then later dinosaurs, started to take over, reaching their peak during the Jurassic and Cretaceous. And then, of course, came the KT extinction, in which a massive asteroid hit the Earth, wiping out all of the non-avian dinosaurs. The explosion would have been equal to about 1 billion Hiroshimas, but it wasn't just the actual impact that caused the extinctions. It was the aftermath, too. Initially, there would have been radiation, firestorms, and tsunamis. But then perhaps worst of all that debris thrown up in the air would have blocked the sun for about 2 years, meaning that plants couldn't perform photosynthesis. But it was this event, as well as the previous 2 extinction events, that helped drive the evolution of mammals. One theory is that once the dinosaurs became dominant, the main proto-mammals to survive were the smaller nocturnal ones, because they were better at hiding from big predators. This helps explain some of the additional changes that occurred to synapsid skulls. You see, another feature of later synapsid skulls is that the jaw is made up of just one large bone, whereas the jaw in sauropsid skulls is made up of several bones. So what happened to those other jaw bones? Well, we synapsids actually still have them, but ours are really, really tiny and located in our ears. They help us to hear much better than reptiles and birds do. Synapsid skulls also developed a secondary palate, which separates the nasal cavity from the oral cavity. This allows us to smell much better than reptiles and birds do. But whereas synapsids have superior hearing and smelling, sauropsids have better vision. They have 4 cones in their eyes, whereas we have only 3, and most mammals have only 2. This all makes sense if we consider that our synapsid ancestors were mostly nocturnal. If you're moving around in the dark, being able to distinguish between colors isn't really all that important, but being able to hear well and smell well is. Another feature that proto-mammals developed was the ability to regulate their own temperature rather than simply relying on the sun for warmth. This requires a lot more energy, but it paid off because warm-blooded creatures are more adaptable, being able to grow faster and survive in different environments, including cold nights and deep holes underground. One way proto-mammals managed to regulate their temperature was by developing fur. Another was by developing the ability to secrete fluids, like sweat, for example. Which brings me to the feature for which mammals get their name, mammary glands. Mammary glands produce milk, which mothers initially used not to feed their babies, but simply to keep their eggs moist. Over time, however, it ended up being the primary food source for mammal newborns, which allowed them to stay closer to their mothers, and hence away from predators. Now, we tend to think of all modern mammals as being live bearers, but there are still a few around that lay eggs, such as platypuses and echidnas, both of which live in Australia and belong to the monotreme order. Monotreme meaning one whole. This is a reference to the fact that they, like birds and reptiles, have just one whole that they use for all their bodily functions. All other mammals are therians, meaning beasts. And they can be divided into 2 categories, marsupials, which again only live in Australia, and placentals. Marsupials give birth to live young, but in a not quite ready state. Once they leave the womb, they crawl up into a special pouch called a marsupium, where they continue to develop a little more. Now, the marsupials that you're probably most familiar with are kangaroos, but there are others still around like koalas, wombats, and opossums. And up until around 60,000 years ago, there were many more as well, some of them quite large, like the rhino-sized Diprotodon and the cat-like Thylacoleo. The vast majority of mammals, however, are placentals, meaning that they develop placentas during pregnancy, which feed their young until they are fully ready to be born. So no egg and no need for a pouch. Now, in order to explain the two main branches of placentals, Boreoeutheria and Allantogenata, I need to first tell you a bit about prehistoric continents. As you probably know, there was once just one big supercontinent on Earth called Pangaea. It existed during the Triassic period, which was right around the time that the very first mammals appeared. But then, during the Jurassic period, it started to break up, with Australia coming off first, which is why the mammals there are so different. Eventually, though, the largest chunk of Pangaea split into two main parts, Laurasia in the north, being comprised of what would eventually become North America, Europe, and Asia, and Gondwana in the south, which was basically South America and Africa squished together. So the reason why we have two main types of placentals is that the Boreoeutherian mammals initially evolved in Laurasia, whereas the Atlantogenatan mammals initially evolved in Gondwana. Let's look at Atlantogenata first. It can be split further into Xenarthra, which developed in West Gondwana, and Afrotheria, which developed in East Gondwana. Xenarthra means strange joints, and they are so named because they have some extra parts in their spine. Examples include armadillos, sloths, and anteaters. In contrast, Afrotheria consists of aardvarks, manatees, and most notably, elephants, including the two main types still alive today, African elephants and Asian elephants. However, if we were to go back just 4,000 years, there would be a third kind as well, mammoths. For the rest of this video, we'll be dealing with Boreoeutheria, which can also be split in two. First, there's Laurasiatheria, which is named after that northern supercontinent I mentioned earlier. Here we find hedgehogs and bats, as well as all of the hooved animals, called ungulates. These in turn can be divided into Perissodactyla, meaning odd-toed, and Artiodactyla, meaning even-toed. Those with an odd number of toes per hoof include horses, who have just one, and rhinos, who have 3. In terms of even-toed ungulates, hippos, pigs, and deer all have 4 toes per hoof, whereas the rest have 2, such as giraffes, camels, and bovids. Bovids being the family that includes cows, sheep, and goats. But also included in Artiodactyla are a group of mammals with no hooves at all, at least not anymore. These are the cetaceans, like dolphins and whales, who now live exclusively in the water, but who evolved from hippo-like ancestors who once lived on land. Finally, within Laurasiatheria is the carnivore order, where we find humanity's 2 best friends, cats and dogs. In fact, this entire order can be split in 2 between the cat-like carnivores, called Feliformes, and dog-like carnivores, called Caeniformes. In Feliformia, we find hyenas, as well as the Felidae family, which includes cougars, cheetahs, bobcats, and the now extinct saber-toothed tigers, and panthers. Tigers, lions, and leopards are actually all panthers, even though we tend to reserve the word panther only for black panthers, which are actually black leopards. And then, of course, there's the Felis genus, which includes the African wildcat, from which the domestic cat, Felis catus, evolved. On the dog-like side are many different families, such as the ones with bears, skunks, raccoons, seals, and otters. But then, of course, there's Canidae, the dog family, which includes foxes, coyotes, and wolves. It was from the gray wolf, Canis lupus, that the domestic dog evolved. Okay, so that takes care of Laurasiatheria. Let's now look at Euarchocontoglires, which is so named because it is made up of Euarchoconta, meaning true rulers, and glires, which means mouse. Glires has more than just mice, though. It includes rabbits, as well as all the rodents, which can be divided into beavers, porcupines, squirrels, capybaras, rats, and hamsters. Euarchoconta includes tree shrews, as well as the most important mammal order of all, at least to us, the primates. Even the word primate itself indicates its importance, as it literally means of the first rank. But again, this is obviously from the human perspective. From an evolutionary perspective, No one branch of the tree is any more important or better than any other. As long as it's still there, it can be considered successful. And even from the perspective of our own definition of intelligence, there are many branches of this tree that have produced highly intelligent life forms. Besides primates, there's also cetaceans, elephants, parrots, and corvids. And way down here, there's octopuses, who are known to use tools. Even pigs are smarter than most people realize. But on the other hand, I don't think we have to apologize for having a particular interest in primates. After all, they are our closest relatives. So let's take a look. First, I'll mention the two prosimian orders, tarsiers and lemurs. All other primates, including monkeys and apes, are called simians, which literally means flat-nosed. Now, a lot of people use the words monkey and ape interchangeably, but they shouldn't because these are actually two very different types of simians. Monkeys are generally much smaller and have tails, whereas apes are bigger and are the only mammals to lack tails. Monkeys themselves can be divided into two main types based on where they first evolved. So there are Old World monkeys from Africa and Asia, and New World monkeys, mostly from South America. In terms of apes, most belong to the hominid family, or great apes. But there's also one family of lesser apes, the gibbons. The great ape family currently consists of 4 genera: gorilla, pongo, aka orangutans, pan, which includes common chimpanzees and bonobos, and finally, homo, humans. As you probably know, humans are most closely related to chimpanzees, which is why I added an extra node here representing their last common ancestor. This ancestor was neither a chimp nor a human, but rather something in between that lived around 9 million years ago. Perhaps something like the now extinct Sahelanthropus chadensis, discovered in 2002. What's more certain is that around 3.5 million years ago, our ancestors were Australopithecines, meaning southern apes. This now extinct genus was first discovered in 1924, but was made famous in the 1970s with the discovery of this partial skeleton, nicknamed Lucy. Since then, more complete skeletons have been found, and the genus has been divided into many different species, and perhaps even multiple genera. Now, before I move on, I want to shout out Etere Matza, who produced all of the images for this part of the tree. You may know his work from the Stefan Milo channel, but if you want to follow Etere directly, you can do so on Instagram. I'll leave a link to his profile in the description. Eventually, one of the Australopithecus species evolved into a new genus called Homo, the earliest known species of which was Homo habilis, meaning handyman, because this species is known to have used stone tools. A little later came Homo erectus, meaning upright man. The first fossils of this species were found in Asia way back in 1891, but since then similar fossils have been found in Africa as well. Some researchers simply call these African specimens African Homo erectus, but others consider them to be a totally different species and instead label them as Homo ergaster, meaning working man. Either way, it is from the African hominid that all humans today descend, by way of an intermediate species called Homo heidelbergensis. But before we move forward towards Homo sapiens, I want to first point out this species here, Homo floresiensis, discovered in 2003 on the island of Flores in Indonesia. This early hominid stands out because it was much smaller than all the other Homo species, perhaps due to island dwarfism. Initially, it was thought that they might still have been around as recently as 10,000 BCE, but more recent estimates have pushed that back closer to 50,000 BCE. There are currently 2 main theories as to where these hobbit-sized people came from. One is that they descended from Asian Homo erectus. The other is that they were actually the remnants of an earlier species, perhaps as old as Homo habilis. But back to Homo heidelbergensis. a species that lived from around 700,000 years ago to around 200,000 years ago, and lived in both Africa and Europe, and perhaps even as far away as China. This species was the common ancestor of Neanderthals, Homo sapiens, and Denisovans. Neanderthal fossils were the first fossils to be recognized as belonging to some type of prehistoric human, as far back as 1856, which was 3 years before Darwin's On the Origin of Species. Nowadays, we have 400 Neanderthal specimens and have completely mapped out their genome, from which we now have firm evidence that Neanderthals and Homo sapiens interbred with each other. In contrast, we only learned about Denisovans in 2010, and we currently only have around 10 specimens. We have, however, mapped out their genome, and from this we have learned that they interbred with both Neanderthals and Homo sapiens. Neanderthals are named after the Neander Valley in Germany, where some of the very first remains were found. And they are generally now seen as being a unique species called Homo neanderthalis. However, the Denisovans, which are named after Denisova Cave in Russia, have not yet been assigned an official name. So that was a look at the evolution and classification of mammals. In the next episode, we're going to go all the way back down to the bottom of the tree and take a look at the plant kingdom and the fungi kingdom. This will then be followed by a final episode in which I'll be talking about the evidence for evolution and how we know that the theory of evolution is true. Until then, if you want to get a copy of the chart, be sure to visit usefulcharts.com by clicking the link in the description, pinned comment, or on screen in a few seconds. Thanks for watching.